Let's see numerical number 1. A student bang a drum in the middle of the rectangular hall. Two echoes are detected at 40 millisecond and 70 millisecond. If the length of the concert hall is 24 meter and there is no echo from the ceiling, what is the speed of the sound in air? Here we have a rectangular hall which has 4 walls. Okay, wall A, wall B, wall C and wall D. Okay, and we have the length of the wall which is 24 meter. Since the student is sitting at the center of the hall, therefore the distance between the wall A and the student is 12 meter. Okay, we have the distance of the wall, we have the distance between the wall A and the student which is 12 meter, and we have the time of the echo that is produced by wall A and C, the greater time, which is 70 millisecond. So here we will apply the formula 2s is equal to Vt and V is equal to 2s upon T. Since we have to find the speed, therefore we will apply the formula V is equal to 2s upon T. Now here we will apply the formula 2s is equal to Vt and V is equal to 2s upon T. So 2 multiply 12 upon 70 into 10 power minus 3 second. So V is equal to 24 divide 70 into 10 power minus 3. Okay, we will solve it further. Okay, we have the distance which is equal to 12 meter times 70 millisecond, which is equal to 70 to 10 power minus 3 second. We have to find V. 2s is equal to Vt, V is equal to 2s upon T. We will put the value of S and T, and finally we will get the result which is 342.85. Now let's see numerical number 2. In an experiment to determine the speed of the sound, a gun was fired and an observer at a distance of 900 meters away measured a time interval between seeing the flash and the gun. Okay, let's the gun was fired at the position A and the person is standing at position B. Okay, and when he see the flash of the gun, he started his stopwatch, and when he hears the sound of the gun, he stopped his stopwatch and he measured the time interval, from which the sound covers the distance of 900 meter. That sound covers the distance of 900 meter is 2.5 seconds. So here we have the distance between point A and point B which is equal to 900 meter, and we have a time which is equal to 2.5 seconds. From this time, the sound cover a distance of 900 meter, and we have to find the speed of the sound. We will apply the formula S is equal to Vt and V is equal to S upon T. We will put the value of S and T in this formula and finally get the result which is 360 meter per second. Now let's see the another one numerical number question number 3. Now let's see the numerical. A man stands between two walls. After making a loud clap, he hears two echoes at an interval of 1 second. If the distance between the two walls is 1000 meter, okay, what is the distance from the nearer wall? Here we have the two wall A and wall V, and a person is standing between these two walls. We have two wall A and wall B, and a person is standing between two walls. Okay, we know the distance between the two walls which is equal to 1000 meter. Okay, now the distance from the nearer wall B is represented by S1 and the distance from the far wall is represented by S2. Okay, since, and we know that S2 is greater than S1. The echo produced by the wall S1 in the time interval is represented by T1. Okay, and the echo produced by wall A is represented by in a time which is represented by time T2. We know that T2 is greater than, we also know that T2 is greater than T1. Okay, now here as we know that S2 is greater than S1 and T2 is greater than T1, and we have a time difference. Okay, so T, which is time difference, which is equal to T2 minus T1. Okay, according to the formula of echo, 2S is equal to VT, 2S2 is equal to VT2, and T2 is equal to 2S2 upon V. So we will write 2S2 upon V in place to T2 and 2S1 upon V in place of T1. So we will take the LCM of V. The LCM would be V. So it will become 1 is equal to 2 S2 minus S1 V. We will put the value of V, which will become 1 is equal to 2 S2 minus S1 upon 300. We will cancel is 2 ones are 2, 2 150 are 150 by cross multiplication. 150 is equal to S2 minus S1. Okay. Now listen. Now we have two equations. S2 minus S1 is equal to 150 and S1 plus S2 is equal to 1000. We will solve these two equations simultaneously. First of all, we will add these two equations, and which will become 2S2 is equal to 1150 and S2 is equal to 1150 divided by 2. So S2 is equal to 575. We will put this value in equation number 2. S1 plus S2 is equal to 1000. S1 is equal to 1000 minus S2. So 1000 minus 575, which is equal to 425. Now here, equation number 4, we have a diagram of the longitudinal waves. We know that one complete compression and one complete rarefaction is equal to one wavelength. Okay, so here we have 3 wavelength, and the distance of 3 wavelength is equal to 12 meter. So here we have 3 lambda is equal to 12 meter. Lambda is equal to 12 upon 3. 3 1 are 3, 3 4 are 12. Lambda is equal to 4 meter. Okay, thank you very much.